Part 3 of this tutorial puts the final touches on the analog clock we have implemented in the first 2 episodes. So this is about highlighting these hour ticks, and with the techniques we have already developed, we could go about this quite easily. Just load in 12 of these highlight PNGs, set the rotation angle for each of them, and then render up to 12 of these in our render loop. Of course, this would be quite inefficient, since that means we would upload 12 times the exact same image along with its geometry to the GPU. What we can do instead is to load the image only once and then change our renderer in a way that we can draw multiple instances in different places from the same image. In order to render a single image multiple times, we need to extend our platform render image API to pass in also the number of instances we want to draw. Up to this point, the only data point we needed to render an image was the texture ID. With the number of instances, this has now changed, so now I will add a draw call struct which includes the texture ID and the number of instances, so that our renderer knows how often it needs to render the same image. Our current array of render IDs will be replaced by an array of these draw calls, so that in our render loop, when we iterate over all the draw calls, we have the texture ID and the number of instances to pass through the GPU. With a data structure to hold the texture ID and the number of instances, we can now change all the interfaces inside of the renderer to take in the number of instances as well. And in the end, we will just fill in the spot in the array with the texture ID and the number of instances, and delete the old render IDs. After removing the array of render IDs, we now need to go into the render function and change here everything to draw calls. So we iterate over the number of draw calls, grab out the texture ID from each call, and get the vertex buffer, the texture, and the model buffer that way. And the last piece is here to change the draw primitives call to include also the number of instances. So this is this last parameter here, instance count. With all that done, the main vertex shader now also receives an instance ID, telling it the running number of the current image to be rendered. Obviously, we missed to delete a couple of things from our previous implementation, and then we also missed to include the new instances parameter to the private render image function of our renderer. With all that done, the compilation should work again, and we can go ahead now and include the highlights image into our clock app structure. This next part is basically a repeat exercise of exactly what we did in the last episode. So I'm going to load the image from the file system, then create a new model data structure, and fill in the rotation and model data matrices with meaningful values. In this case, I already know a couple of the magic numbers to position the highlight in the exact correct spot. Once we have configured both the pivot and the model matrix, we can assign the whole thing to our image structure and upload the whole thing to our renderer and then to the GPU. Now all the necessary parts should be in place, and we can use our platform render image function, which is now capable of taking in the number of instances as well, to draw the highlight. So first compile and test shows that it works and that we see the highlight in the 12 o'clock position. So now we of course need to adapt the code a little so that we draw all the highlights in the correct place according to the current time. The current time is calculated in our update clock function, so we need to store the number of hours in our abstract so that we can reuse this in the render function. And here we just pass it to the render image function, so now we are drawing as many instances as we have hours, and that also is reflected in this very pronounced highlight. with all the current changes, we are already rendering instanced. So however many hours we pass in, this highlight is drawn, but it's drawn in the same spot. So what we need now is to calculate the rotation for 1 hour, and in the shader we can then just multiply the instance ID, which is our index for the hours, by the incoming rotation. And here we need to add +1, because otherwise all the other rotations of all our other images would be calculated rotation multiplied by 0, and that is not what we want. The result here is still a little wrong, and that's just because we are rendering counterclockwise and not clockwise. So minus 180 by 6 should fix everything, and we have highlights for our clock. The next video is going to be a small Christmas special where I would like to show how to use what we learned today to implement a small particle system which generates snow. Until then, have a good one.